welcome to a quick review of special right triangles. Now, there are two main types of special right triangles, which consist of the 45-45-90 right triangle and the 30-60-90 right triangle. Now, special right triangles deal with the ratio of side lengths in comparison to the opposite angle. Now, the first main triangle we're going to focus on is the 45-45-90 degree right triangle. So for the ratios of each of the side lengths, they consist of S, S, and S root 2. So you may be confused about this, but I'm going to clear it up with a diagram off to the right. Now, the opposite side length of each of the 45 degree angles have a value of S, and the hypotenuse, which is across from the 90 degree angle, will have a value of S root 2, or the value of the 45 degree angle times the square root of 2. So where does all this come from? So because of base angle theorem, which states if two angles in a triangle are congruent, then the side lengths opposite them are also congruent, forming an isosceles right triangle. So all of these ratios come from Pythagorean Theorem. So you take s squared plus s squared equals 2s squared. Now this simplifies down to s times the square root of 2, which is the side length ratio opposite the 90 degree angle. So, for example, if we plugged in a value such as 2, we do Pythag, 2 squared plus 2 squared equals 8 squared. So this simplifies down to root 8, which is 2 root 2. 2 is equivalent to s, which is the same as s times square root of 2, which is equivalent to the ratio. Okay, so the second special right triangle we're going to focus on is the 30 degree, 60 degree, and 90 degree right triangle. Now this one's a bit more complicated because it deals with multiple ratios. The first one, which is opposite the 30 degree angle, is still S, which is the shortest leg. And the side length opposite the 60 degree angle is S root 3. And then the side length opposite the 90 degree angle is 2 times the length of the 30 degree side length. Okay, so to prove the ratios of a 30, 60, 90 degree special right triangle, we must look at an equilateral triangle. Now, for each side, we're going to label it 2s. And each angle is going to be 60 degrees because it has to add up to 180 degrees in a triangle. Now, if we were to draw an altitude from B to D, it would create two 30, 60, 90 degree right triangles. Therefore, splitting this 60 degree into two 30s, and DC would be 1/2 of AC. So this would be S. Now, if we were to do Pythag, we would set up the equation S squared plus BD squared equals 2s squared. Now this would simplify down to s squared plus 3s squared equals 4s squared, because this must add up to 4s squared. Now, if we were to take the square root of 3s squared, it would equal s times root 3, which is the opposite of the 60 degree angle. Therefore, equaling the ratios of a 30, 60, 90 degree right triangle. So thanks for watching, everyone. Hope you learned something new, and if you have any questions, just leave them in the comments section below.